So in the second lesson, we're going to take a closer look at R objects. Specifically, what we're going to do is I'm going to show you how to create and use vectors, factors, data frames, matrices, arrays, and lists. And we're really going to talk a little bit more about what exactly is the difference between these different types of objects in R. We've kind of seen vectors a little bit. We've talked briefly about factors. We've seen data frames in the last module. We've kind of seen all of them a little bit, but it sounds a little bit hard when you first get into R to really appreciate the difference between these different types of objects. I will also have to spend a little bit of time thinking about how to handle missing values. Again, we've seen this a little bit in the last lesson where we converted a vector of mixed types of, I should say, of characters to a numeric vector, but then the conversion couldn't happen for one of the values, and we got an NA to indicate a missing value. We're going to have to take a closer look at how to do this. So let's start by first looking at vectors. So vectors we've seen before, and vectors is the basic storage data type in R. In fact, if you don't do anything special, you get a vector. A vector holds a collection of values of the same type, either numeric, logical, or character. You can't have a mixed mode vector. That doesn't work. If you add different mode elements to a vector, they all get converted to the same mode at some point in time. Now, a vector is somewhat similar to an array, although an array in most programming languages has a fixed length. Vectors in R grow and shrink depending on how many elements they have in it. So it's really a lot closer to an array list or a vector in other programming languages like Access. But it does allow element access through indexing. So that means that you can go ahead and look at particular elements by using array access manipulation, so indexing manipulation. So here's an example of how to do this. Now be sure that as I talk through the examples here that you get a chance to fire up R or RStudio and type in these commands and actually walk through the slide deck by trying out what I'm talking about in R, and then make some mistakes, make some manipulations, and see what kinds of error messages you get. So you become attuned to the error messages and how R reacts when you do something incorrect. That allows you to much more quickly debug your programs later on. But in any case, here we have a vector of 6 numbers, 1, 3, 5, 8, 13, 21, right here. And then if you say numvec sub 3, I get the third element, 1, 2, 3. Interesting to note are indexes starting at 1, which is different than some other programming languages like C and C++ and Java, which start indexing at 0. JavaScript and many others also fall into the same category. The next object I'd like to take a look at is factors. So again, we've seen a little something about factors in the previous lesson, but again, we didn't dig much into it. So the factor type is used to encode categorical data values. Categorical data values are those that have different categories, like semester having fall, winter, and summer, or seasons having fall, spring, winter, and summer, or maybe having categories of membership in a club, gold, platinum, silver, bronze, and so on. So those are examples of categories. Now, while a vector can have any number of distinct elements, a factor variable would be limited to its categories. So if you set up a factor with the categories fall, winter, and summer, then any variable could only take on those values. You couldn't take anything outside. It's almost like a restricted list of values. Now this is very important for certain types of statistical hypothesis testing and modeling, like building an ANOVA. The reason why we need to do that is because factors are stored much more efficiently than simple text strings, and it also allows certain types of processing and statistical analysis because internally they're really numbers. So factors are stored as numbers internally. So factors are created using the factor function, which requires a vector of category values as input. So here's an example. So we have the category vector AA, BA, JB, and CO. Let's say we've got a bunch of airlines. Then we use the factor function to make that into a factor. So now we have the factor variable F1, which consists of the factors AA, BA, JB, and CO. What's also interesting is that if you look at the labels, for F1 I get 1, 2, 3, 4, so it actually encodes them as internal numerics. And then the levels of the factor are AA, BA, CO, and JB. So there is an internal correspondence between the numbers and the actual category variables, or category values. Now, while factors are stored as unique numeric labels, they are not in fact a numeric data type, which is a little bit confusing because they are stored as numbers, but you really can't use them for numeric manipulation. They're used in statistical functions that way, but you can't really do calculations on them. In fact, if you try to do that, like, let's say you try to calculate the mean of a factor, it wouldn't work. It would tell you that it's not numeric or logical, and returns you an NA, a non-available value. So far we've talked about vectors and factors. We're going to go on in part 2 and take a look at data frames, one of the most important types, along with the data matrix. And then later on we're going to take a look at arrays and lists.